Hi guys! So welcome to another lesson, and today you will be able to understand the changes in dimensions such as length and widths of similar geometric figures affect the perimeters all around and then the areas inside if you're trying to fill in of the figures. So we're going to look at two different key ideas, very similar to one another. The first one is perimeter of similar figures. When two figures are similar, just like this one, the ratio of their perimeters is equal to the ratio of their corresponding side lengths. So when you look at this, the perimeters of these two figures, given that these two figures are similar, is equal to any of these ratios. So AB is corresponding to DE, BC is corresponding to EF, and then AC is corresponding to DF. So as long as you're given that these two figures are similar, we can set up proportions using any of the dimensions, corresponding dimensions. Let's look at the first question. Find the ratio of red to blue. That's important, red to blue, of the perimeters of the similar rectangles. Notice I highlighted those two words. I needed to find out the ratio of from red to blue, not blue to red, of the perimeters of similar rectangles. So it's already given that these two figures are similar. So you're not going to be able to use that key idea that we just spoke about unless you know that the two figures are similar. So here we're going to represent perimeter of the red rectangle, over perimeter of the blue rectangle is equal to the width of the red, which is 4, over width of the blue, which is 6. And make sure you reduce your fraction, simplify your fraction to the simplest form, which is 2/3, and that's it. Very simple. So now let's look at the second concept of this lesson, area of similar figures. When two figures are similar, again, the ratio of their areas is equal to the square. I'm going to highlight that. Square of the ratio of their corresponding side lengths. Same as the perimeter, except that you're going to square the dimensions. Let's look at the second question. Find the ratio of, from red to blue, of the areas of the similar triangles. So we're going to set up area of red triangle, area over the area of blue triangle is equal to, we're given these two dimensions, so we're going to have to use them. So red is 6 over 10, which is the blue. But the only thing, because we're talking about the area, we have to square this fraction, this ratio. So I'm going to put parentheses and square it. But I need to always simplify. I'm going to simplify the inside first. So 6 over 10 becomes 3 over 5. How? I'm going to divide top and bottom, both the numerator and the denominator, by 2. So 6 divided by 2 is 3. 10 divided by 2 is 5. Then I'm going to square this fraction. But remember back in chapter 10, when we put an exponent outside the parentheses and over for the fraction, it really means we're going to distribute the 2 or the square to both the numerator and the denominator. So that really means 3 squared over 5 squared, which means 3 times 3 on top and 5 times 5, which is 9 over 25. And that's your final answer. I hope this video made sense. And thank you so much for watching. If you have other questions or if you want me to clarify something, please reach out. You can message me. We can also set up a Zoom session. Make sure you reach out to me. What you could also do is follow me on Instagram at 4minmath and also subscribe to the YouTube channel for more math videos. See you next time. Bye.